Hi, this is Joyce Farrell. Let's take a look at the logic behind creating and using a linked list. Linked lists are structures in memory or in storage in which each record that you store contains an extra field that holds a link to the record that comes next logically. The advantage of using a linked list over an array is that you can quickly process an entire linked list in a different order than the order in which it's physically stored. The disadvantage to using a linked list compared to an array is that with an array you can access any element directly using a subscript, but with a linked list you can't access any element directly. You must traverse every link in the linked list to get to the record that you want. Records in memory or in storage may certainly have a different physical order than their logical order. For example, records might have a logical order 1, 2, 3, 4, but be stored 1, 4, 2, 3, as shown here. With a linked list, record 1 would carry an extra field that shows the address of record 2. Record 2 would have an extra field that has the address of record 3. And record 3 would have an extra field that points to record 4. Record 4's link would indicate that it's the end of the list in logical order. Let's look at some storage locations and just number them 101, 102, and so on. Let's assume we want to add some records to these storage locations with ID numbers, last names, and pay rates for employees, and each record will also contain a field that holds the address of the next logical employee by ID number. Suppose the first record is stored at address 101 and it's for ID number 912, last name Brown, pay rate $12. The next field holds null because null is a special value that indicates there is nothing next. There's only one record in this list. So we've reached the end of the list. When we add a new record, suppose it's stored at address 102 and has ID number 925. To figure out the next field for this record, you start at the beginning of the list. You look at address 101 and you decide whether the new ID number, 925, is less than 912. It's not, so you process the next record. But the next record is null. So because 925 was greater than 912, the new record should have a next value of null, and the previous record should now point to this new second record and have a next address of 102. Let's add a third record to the linked list. Suppose this one is stored at address 103 and the ID number for the employee is 918. To figure out the value of the next field, we'll start at the beginning. At address 101, the ID number is 912. The new record 918 has a greater ID number, so we'll continue looking. Go to the next address, which is at 102. That ID number is 925. 918 is not more than 925, so the new record should point to the 925 record at address 102, and the record that used to point to 102 should now point to 103. If you wanted to process this list in order by ID number now, you'd start at the beginning, address 101, you'd use the data for record 912, and then you'd look at address 103, skipping spot 102. At 103, you'd process the data for that record, and then go to address 102. At 102, you'd process that data, and you'd reach the end of the list. Let's add a fourth record to the list. This one happens to be stored at memory location 104, and the ID number is 915. To figure out the value of the next field, you'll start at address 101. 915 is bigger than 912, so you continue and go to address 103. At address 103, the ID number is 918. 915 is not bigger than 918, so the record at address 104 with ID number 915 should point to the record at address 103, and the record that used to point to address 103 should now point to 104. If you process the list in order, you start at 101, use that data, go to address 104. At 104, use that data, go to 103. At 103, use that data, go to 102, And after you go to 102 and use that data, you've reached the end of the linked list. That's a quick introduction to linked lists. Thank you for watching.